So, leading into a talk on active galaxies. First thing is the active galaxies are powered ultimately by a central black hole. Central because it's down at the center of the galaxy. We generally also call this a supermassive black hole, abbreviated SMBH. Of course, we abbreviate everything in astronomy. The supermassive black holes were really, they'd been suspected to be there for a long time, but pretty solid confirmation finally came in the mid to late 1990s. There was a paper that came out that had a census of about 36 of these. And for the first time, we felt really confident that here was a solid population of black holes at the centers of galaxies, and that the black holes seemed to be, the black hole masses seemed to be proportional to the mass of the galactic bulge. So if you've got a spiral galaxy, the bulge is where you've got the spiral disk, where the spiral arms are, and you have the bulge, which is at the center. So the black holes tend to be, I'm trying to remember, it's about maybe 0.5% the mass of the bulge. And there's some uncertainty and variation on this. If you've got an elliptical galaxy, then you can consider the entire galaxy to be bulge with no disk. So these black holes have a mass proportional to the mass of the bulge. And this got to be well enough established that we figure that there are black holes at the centers of basically every galaxy. And if you find a galaxy without a black hole, that was actually worth a paper nowadays rather than finding a black hole was. So why are there black holes at the centers? Well, we can talk about something called dynamical friction. If you think of a galaxy as being like a gas, where instead of individual molecules floating around, you've got the individual stars. The stars act sort of like the gas molecules. And as the stars orbit the center of the galaxy, then whenever two stars get close enough to each other, they can feel the gravitational pull from one to the other. They fix each of their orbits. But when you have a black hole, black holes tend to be more massive than the stars, even when they're starting out. And so the black holes, in an encounter between a black hole and a star, the black hole winds up getting dragged down a bit closer to the center. It loses some of this orbital energy, while the much lighter star gets flung out. It gains kinetic energy. And this is sort of like the atmospheric drag on a satellite up in the upper atmosphere. There's atmosphere even going up onto the edge of space. So you've got the massive satellite. Every time it encounters one of these gas molecules in the upper atmosphere, the satellite loses some of its speed and falls down a bit closer to the Earth, while the gas molecules generally gain speed and are bumped out. So this tends to drag a black hole from anywhere out in the galaxy down towards the center, in fact, pretty quickly. Where do these black holes come from? We're still not totally sure about this. I mean, maybe they come from normal type 2 supernovae, the explosions of massive stars. And so they start off as a 3 solar mass or a bit larger black hole somewhere out in the edges of the galaxy, and then they get dragged down. But that's a lot of mass to gain, because the central black holes in these massive galaxies, the supermassive black holes, might be several million or even a few billion times the mass of our sun. So how do you get a black hole that massive in just a few billion years? There's some other thinking that maybe there are primordial, or were primordial black holes made around the time of the Big Bang, and that these were maybe a few thousand solar masses. And so they would have already had a head start and could have gobbled up a lot more material. So we're still unsure about just how these things start. But once they're made, get dragged down to the center, they can grow from there. Why do they grow at all? Well, in most galaxies, the central black holes are sitting there minding their own business, not really doing much. As stars orbit around the center of the galaxy, the stars don't really fall down to the middle, just like the planets orbiting around the sun orbit around the sun. They don't fall down into the sun. Only things with really elliptical orbits, narrow elliptical orbits, like comets in our solar system, actually fall into the sun, and not even always then. So it takes something to get it to fall down in there, to get material to fall into that central black hole. This can come from, possibly galaxy collisions, mergers. When you get those kinds of things, the tidal forces between the two galaxies can wind up funneling a lot of the interstellar medium, the gas, in the galaxy down to the middle. You could also have in barred spiral galaxies, the bar shape can wind up channeling some of that gas down to the middle as well, and there's some other ways also. Warped disks, I don't know all about these. So if you can get the fuel down to the middle, that's the tricky thing. You've got to make it lose angular momentum to fall down there. Now, once you get gas falling down to the middle, where it can get into the black hole, this is what can power an active galactic nucleus. The nucleus here refers to the center. Nucleus just meaning center. An active galaxy is opposed to a normal galaxy. Normal galaxy is where the black hole minds its own business. In an active galaxy, the black hole is actively swallowing up gas and some dust and maybe the occasional star that it might rip apart as well. We've recently found some of these things. So next we'll talk about the active galaxy.